13.4 Effects of wildfires and linkages with other natural hazards. Effects of wildfires on the geologic environment depends on type and moisture content of soil, duration and intensity of fire, and amount and intensity of precipitation after a fire. Why do you think these factors matter to the effect of wildfires on the geologic environment? Well, let's see if we're thinking along the same lines. The amount and intensity of precipitation after a fire will greatly affect the amount of erosion of the burnt area. The duration and intensity of the fire affects how easily the area will recover from the fire. Did the fire burn the trees all the way to stubble, or did it just mostly harm diseased trees and grasses, etc.? And the soil, well, we talk about that on the next slide. Fire can cause soil changes when the fire is extremely hot and on dry, coarse soil, which may leave a water-repellent hydrophobic layer which can last for several years. This hydrophobic layer increases runoff and erosion and flood events. The series of 3 images below depict first a wettable soil prior to the extremely hot fire, then the fire and the creation of the hydrophobic layer, which remains after the area is burned, as depicted in the last picture. Wildfires can also exacerbate soil erosion and landslides, as I bet you recall from studying mass movement. As the wildfire removes anchoring vegetation on steep slopes, the slope is more likely to fail. Basically, the safety factor is reduced. Precipitation often exaggerates the effect of fires on landslides by added weight to the naked slope. Increased erosion and landslides last for a few years after a wildfire in landslide-prone areas, until new vegetation begins to grow. However, there is not much increase in mass movement in areas not prone to landslides to begin with. The picture is of a landslide that occurred in California in 2010. The slope was already more unstable than normal due to recent fires that swept across the mountain less than 1 year previously. Heavy rains contributed to the mud flow in the picture. The huge landslide closed a highway and caused structure collapse of the roadway. You can see in the picture Los Angeles County DOT crews excavate and repair the highway. Moving on to the effects of wildfires on the atmospheric environment. Wildfires create their own clouds as they release smoke, soot, and gases that contribute to air pollution. You might already be aware of this. Wildfires also contribute to smog formation, which includes some non-human friendly gases, such as carbon monoxide, volatile organic carbons, or VOCs, and nitrogen oxides. With sunlight, these compounds form ground-level ozone, which we don't like, though we do like stratosphere ozone. An example of wildfire-related ozone is from a 2004 wildfire in Alaska, which caused an increase in ozone levels by 25% in areas of Canada and the United States, and by 10% in areas of Europe. The image below is a picture taken from onboard Air Force One on August 2010, showing smog settling in valleys, Nevada. So, would you believe me that climate change may increase intensity and frequency of wildfires? Why do you think that climate change may increase frequency and magnitude of wildfires? Well, here are some reasons. Climate change is causing changes in temperature, precipitation, and the frequency and intensity of severe storms. Lightning strikes increase ignitions in some areas, specifically much of the western United States. which is already more prone to the wildfire hazard as compared to the rest of the United States. Climate change is causing not only increases in temperature, but also decreases in humidity. Grasslands and shrubs are replacing forests, creating fuel that burn much more easily. Also, insect infestations that thrive with longer reproductive seasons created as temperatures rise make trees more vulnerable to fire. The image below is of the forest in the Black Hills in South Dakota. Perhaps it should now be called the Brown Hills. Each brown tree is suffering from the pine beetle infestation, making this forest more vulnerable to the wildfire hazard. And then think about increased temperatures creating longer fire seasons, decreased precipitation, and more lightning strikes. This forest is looking pretty toasty to me. Now on to effects of wildfires on the biological environment. Fire can destroy some vegetation, however, many plants are fire resistant. Examples include Douglas and Ponderosa, which have thick bark. Oaks are fire resistant by releasing lots of water vapor. Fire weakens other vegetation, making them more susceptible to disease and drought stress. In contrast, some plants use fire to propagate. In particular, they use heat and chemical cues. There are many examples. Sumac and bearberry, manzanita, camise, shrub oak, eucalyptus are very fire prone, practically bursting into flames, and their ashes fertilize the ground. The fire also clears the ground and opens seed pods. Some wildflowers need wildfires to thrive. They are often some of the first vegetation to repopulate a burned out area. Very pretty, as the picture below demonstrates. Some pines, such as lodgepole and jack pine, require fire to melt wax on cones to release seeds. For aspen and many native grasses, fire stimulates growth from the roots. In a summary of studies, 92%, 135 of 146, of native plants studied in North America benefit from fire. Seems these plants have evolved with wildfires, huh? Effects of wildfires in the biological environment for animals is a bit different than for plants. Most swift animals flee unharmed, while burrowing animals are often fine underground, unless their burrows are really shallow and/or it's a ground fire. Aquatic life may suffer from increased sedimentation and temperature increases due to more sunlight hitting the water, i.e. less vegetation shading the water. Regardless of whether the animals survive the wildfire, habitats are altered. The images are of animals affected by wildfires. The image on the left is a swift deer fleeing a fire. The image on the right is of a koala that was caught in a large wildfire in Australia. Koalas are very attached to their specific types of eucalyptus trees, and we know that eucalyptus trees burn very well. Well, the attached koala gets their feet burnt, and then amazingly kind and patient Australians bandage the feet of the scared wild animals. Cute, huh? Humans are also part of the biological environment. Some wildfire consequences for us include water quality degradation. An example is increased manganese in the Denver, Colorado water supply after wildfires in the watershed. Too much manganese can affect the central nervous system. Bad. Another wildfire consequence for us is smoke and haze, producing eye, respiratory, and skin problems. These respiratory problems can become permanent and/or fatal. Darn it. And wildfires also can destroy personal property, especially at the wildland-urban interface. The picture on the left shows one such wildland-urban interface in San Diego in October 2003. The picture on the right is of smoke and haze that is probably producing a lot of eye, respiratory, and skin irritations to the residents of Denver, Colorado in July of 2012. 13.5. Natural service functions of wildfires. There are many benefits to soil, plants, and animals from wildfires. For soil, a wildfire generally increases nutrient content and reduces populations of microorganisms, including those microorganisms that may degrade the quality of the soil. For plants, a wildfire reduces the number of species of plants, so some species end up thriving. Wildfires also trigger the release of seeds of some species and stimulate the growth of some other species, as previously discussed. Wildfires remove surface litter, allowing grasses and other low-lying shrubs to thrive. In addition, wildfires kill some plant diseases and aids in recycling nutrients trapped in plants and dead plant litter, which is what makes the soil more nutrient-rich. Animals, in turn, benefit from the increased plant life. Yummy, tender plants. The two images show some plants thriving after a wildfire.